Welcome students, measuring space, perimeter and area, end of chapter exercise. Identities in algebra can sometimes be as shown as area relationship. Look at the diagram. Here we are having side length a plus b, here also a plus b. So this is the square of side a plus b. This side also we are getting a plus b. Here also we are getting a plus b. So we know that area of the square, area of square formula is side square. So a plus b the whole square. The same area of square, if we are calculating with the occupied space, look at the occupied space here, a squared, this portion is a squared and b squared and ab, then ab, again ab. So when we are observing the area with the occupied space, we are getting a squared plus ab plus ab, which is a squared plus b squared plus 2ab. So using the area squared formula, we are getting the identity as a plus b the whole squared is equal to a squared plus 2ab plus b squared, in such a way that we can get a diagram for a plus b into a minus b is equal to a squared minus b squared. Let's see that. Now take a square of side a. So the first diagram showing here a square with side a, so that the area, occupied area is a squared. This is diagram 1. In diagram 2, we are going to remove a small square from the diagram 1. From the diagram 1, we are going to remove a square with side b. So here b squared, we are going to remove the square. So after removing this, in third diagram we are getting occupied area is nothing but a squared minus b squared. The third diagram is not a regular shape, we cannot use any formula, but comparing 1 and 2, diagram 1 area is a squared, diagram 2 we are removing the square b squared from the a squared. The remaining occupied space is nothing but a squared minus b squared. Look at the sides. When we are seeing the side, this side length is a remains same, here also a remains same, but what about this side? This side is from a we are removing b, so this length is a minus b. Here also, here the total length is a, from that we are removing b, so that this length is also a minus b. Now naming the vertex as 1, 2, 3 vertices. Now this is vertex 1, vertex 2, this is vertex 3, vertex 4, vertex 5, vertex 6. Now using vertices 1 and 4, we are going to cut the figure. Through 1 and 4, we are going to cut this figure. We will be getting two different figures. So through this, if we are separating this, through vertices 1 and 4, if we are cutting, we will be getting two different figures, figure A and figure B. Say this is figure A, this is figure B. So two figures. When we are naming the vertices, here vertex 1, this is vertex 2, vertex 3, vertex 4. Again, this is vertex 4, this is vertex 5, this is 6, this is 1. Now, the length of 1 to 2, look at the third diagram, length of 1 to 2, A, length of 2 to 3, A minus B, length of 3 to 4, B, length of 4 to 5, B, length of 5 to 6, A minus B, length of 1 to 6, A. Now, what we are going to do, we are going to rotate figure B. Now we are going to rotate figure B and we are going to fix the B figure. After the rotation, we are going to fix the B figure beside of figure A as vertex 4 and 1 to fit each other. So look at the diagram 4. This is the diagram 4. After rotating figure B and fixing with the vertex, how we are fixing? This is vertex 1, this is vertex 2, the length of 1 to 2 A, 2 and 3, length of 2 to 3 A minus B, 3 and 4, length of 3 and 4 B. Now fourth vertex fixed with the first vertex. Now this is vertex 4 and vertex 1. Vertex 1 and 6. Then this is 5. And here once again we are getting 4. Now vertex 1 and 4 fixed each other, and here also 1 and 4. We tilted and fixed like this. Now the length of 4 to 5 B, length 5 to 6 A minus B, then length 1 to 6, length 1 to 6 A. So now the side length, that is this side length A and B. So that side length A plus B. So this side you could see B, here A. This is also A plus B. The next side, here you can see A minus B, the downside length also A minus B. Now we are having rectangle. In fourth figure, we are having a rectangle with the side length A plus B and breadth A minus B. What about the occupied area? Just we are changing, that is figure 2. Figure 3 changed as figure 4. We are cutting the pieces and tilting the pieces and fixing, but occupied area is not changed. Occupied area remains the same as A squared minus B squared. Now area of the rectangle in figure 4 is length A plus B into breadth A minus B. Occupied area in the figure 4 is nothing but A squared minus B squared. So A plus B into A minus B is equal to A squared minus B squared. In this way we can get the identity A plus B into A minus B as A squared minus B squared. Now same way we can get the figure for the identity A plus B plus C the whole square is equal to A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA. Look at here. First for A square, take a square of side A. Now we are going to take a square with side A. So side A. So occupied area A squared. Next square with side B. So now we are going to take a square of side B. So this is, we are going to take a rectangle, sorry, not a square. We are going to take a rectangle of length A and breadth B. Length A, because we are keeping beside of A squared, so that same side length, same breadth, same length and different breadth. We are going to take a rectangle of side length A and breadth B. So occupied area here is AB. Completing this, again the same rectangle, we are going to take the adjacent side also. If we need to complete this as a regular figure. So we are taking one more rectangle. Here side length A, breadth B. So occupied area AB. occupied area is AB. Now, if we are completing the remaining sides, if we are drawing a line here with same length of B, this side is parallel to this side, so same length B, and again completing this, above we are having side B, so same side length. Using a square, we are completing this as a regular shape. So now all the sides are B, so occupied space of this is nothing but B squared. Now I am going to take another rectangle of breadth C. Going to add one more rectangle which has breadth C, side length same as A. Here also, and side, both the sidewise, lengthwise and breadthwise, I am going to attach a rectangle of breadth C and length A. So here breadth C, length A, occupied spaces AC. Here also C, this is again A, so occupied spaces AC. Now completing this, once again here what we can get? Here the same B, length B, here we can get length B, here we can get length C, so that we can complete that figure. So now this is the rectangle with length C and breadth B. So occupied area is BC. Then completing this side, if we completed with the parallel sides, now here this is C, this is B. So rectangle of sides C and B, occupied spaces BC. Again one more space is there. To complete that, this is also C, this is also C. So occupied space is C squared. Now look at the side length. Here we are having side A plus B plus C. Then here we are having side length A plus B plus C. Then this is A, this is B, this is C. So here also we are having side length A plus B plus C. Here also we are having side length A plus B plus C. So this is the square of side A plus B plus C. Now the area of the square, as we are using the formula method, area of the square is A squared. Area of the square, side squared. Side squared is A plus B the whole square. Area of square of side A plus B is A plus B plus C the whole square. Same area of square, if we are calculating using the occupied space, look at the occupied space here. First, this one, this is A squared. So write here a squared plus, here we are getting b squared, a squared plus b squared, then this one is c squared, then here we are having a plus b, sorry, ab, not a plus b, a into b a into b AB plus AC, next area plus AC, plus again this one is AB, plus next BC, plus next this one is AC, plus next this one is BC. So A squared plus B squared plus C squared, AB plus AB is 2AB, plus BC is 2BC, AC plus AC is 2AC. So that we are getting the result, area of the square with side A plus B plus C the whole squared is equal to, we are getting the identities result, A plus B plus C the whole squared is equal to A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA. Number 2, an isosceles triangle has perimeter 40 centimeter. The equal sides are 15 centimeter each. Find the area of the triangle. So let's take the triangle ABC. In this side AB is equal to AC means that equal side length given here is 15 centimeter square, 15 centimeter. So this is 15 centimeter, this is 15 centimeter. We don't know side BC. To find that, the given information is perimeter of the triangle. The perimeter of triangle ABC is equal to 40 centimeter. Perimeter of the triangle is sum of all the three sides. AB plus BC plus AC is equal to 40 centimeter. AB is 15 centimeter, BC we don't know, and AC also 15 centimeter is equal to 40. So the length of BC is equal to 40 minus 30 is 10. Length of BC is 10 centimeter. We know all the three sides length. So using Heron's formula, we can find area of the triangle. Length BC is 10 centimeter. For using the Heron's formula, we need S. S is the semi-perimeter. Perimeter by 2 is semi-perimeter. 40 by 2 is equal to 20 centimeter. S is 20 centimeter. So, area of triangle ABC is equal to square root of S into S minus side AB and S minus side BC and S minus side AC. So we are replacing our measurements here. S is 20, 20 into 20 minus 15, 20 minus 10, 20 minus 15 again. So 20 can be written as 4 5s. 4 into 5, 20 into 5 into 10 into 5. So 10 once again written as 5 2s are 10. So 4 into 5 into 5 into 5 2s are 10 into 5, because we need to find square value, no? So we can find the square number inside the square root. So square root of 4 is 2. For these two 5s we can take one 5 outside, and for these two 5s we can take one more 5 outside. 2 is not at all having any pair. So keep square root of 2 as it is. 2 5s are 10, 10 5s are 50. So 50 root 2 centimeter squared is area of triangle ABC. If we are replacing square root of 2 value as 1.414, we will be getting 707 centimeters squared approximately. So area of the triangle here is 707 centimeters squared approximate value. We can use another way to find the area. For that, we know the another formula. If we know to find the height of the triangle, we can use the formula half into base into height. Given as an isosceles triangle, if we are dropping a perpendicular from vertex A, suppose we are dropping one perpendicular from vertex A, say this is AD. If we are dropping a perpendicular from A, this vertex is D. Now let AD is perpendicular to BC. Since it is an isosceles triangle, D is the midpoint. AD is a median also. So BD is equal to DC is equal to half of BC. So BD is equal to DC is equal to half of BC is 5 centimeter, because BC length is 10 centimeter, half of BC is 5 centimeter. BD length is 5 centimeter. So this is 5 centimeter. We know that this angle is 90. So in triangle ADB, AB is the hypotenuse. So to find length of AD, we can replace the Pythagoras as AB squared, hypotenuse squared minus another side squared, BD squared. So length of AD is equal to AB length 15. So 15 squared minus 5 squared. 15 square is 225. 225 minus 25 is 200. AD is equal to square root of 200. 200 is 10 into 2. 100 into 2, so we can write 10 root 2 centimeter. Height of the triangle is 10 root 2 centimeter. Base of the triangle, here base is equal to BC is equal to 10 centimeter. Then height is equal to AD is equal to 10 root 2 centimeter. So area of triangle ABC is equal to half into base into height AD. That is equal to half into BC 10 into 10 root 2. So cancelling this, we will be getting 5. That is equal to 50 root 2 centimeter squared. In this way also we can find the area. Third question. An isosceles triangle has base 10 centimeter and its area 60 centimeters squared. What are the length of the equal sides? So here let's take a triangle A, B, C. The base is 10 centimeter is given. Suppose we are taking equal sides. AB is equal to AC is equal to AB is equal to AC is equal to, we don't know, we need to find what is the equal sides length, and here given is area 60. So area of triangle ABC is equal to 60 centimeter given. If we are using the formula half into base into height is equal to 60 centimeter, half into base here given is 10 centimeter. So height we don't know. Using this we can find the height. 5h is equal to 60. So 60 by 5. Height of the triangle is 12 centimeter. So which is the height? If we are dropping a perpendicular to from one vertex to another side, that is the height of the triangle. So if we are dropping here to here, if suppose this is the height of the triangle, as it is isosceles triangle, that is the median. So name the vertex. This vertex is D. So AD is equal to H is equal to 12 centimeter height of the triangle. Now D is the midpoint. So BD is equal to DC is equal to half of BC, which is equal to 5 centimeter. So in triangle ABD, hypotenuse is AB. So AB is equal to square root of hypotenuse. We need to find hypotenuse. AB is equal to AD squared plus BD squared. So AD squared 12 squared, then BD squared is 5 squared. So AB is equal to square root of 12 squared is 144, 5 squared 25. AB is equal to 144 plus 25, 169. 169 is a square number. 13 squares, 13 square is equal to 169. So we can write 13 into 13. Square root of 169 is 13 square. So 13 centimeter. If AB is 13 centimeter, then AC also 13 centimeter. So length of equal sides is 13 centimeter each. AB, AC is equal to 13 centimeter. Fourth question. The area of the triangle is 54 square centimeter. One of its legs has length 12 centimeter. Find the perimeter. The right angle triangle is 54 centimeter. We know very well area of right angle triangle. Area of triangle, right angle triangle means definitely half into base into height square units. So here it is given 54 and one leg, say ABC is a right angle triangle. Here AB and BC are legs of the triangle. This is the perpendicular. So opposite to perpendicular is the hypotenuse. AC is the hypotenuse. So AB is one leg, BC is another leg. Here given length of one leg is 12 centimeter. Then then here given area is 54. So we can consider our base is 12 and we can find the height. So half into base 12 into height is equal to 54. So when we are cancelling 6 times, 6h is equal to 54. So h is equal to 54 by 6. So 9 centimeter. Height of the triangle is 9 centimeter. Height of the triangle is AB. So that implies side length of AB is 9 centimeter. Another leg measure is 9 centimeter. Now we need to find the hypotenuse. Then only we can find perimeter of the triangle. Hypotenuse AC is equal to, in a right angle, sum of square of another two sides is nothing but hypotenuse. So AC is equal to square root of 12 squared. AB is 9 squared plus BC is 12 squared. So 9 squared 81, 12 squared 144. So length of AC is equal to square root of 5, 225. So 225 is a square number which is 15 into 5, 15. 15 squared is 225. So AC length, hypotenuse length is 15 centimeter. Now we can find perimeter of triangle ABC. ABC is equal to sum of all the three sides, AB plus BC plus AC is the perimeter of the triangle. AB is 9 and BC is 12 centimeter, AC is 15 centimeter. So the perimeter 36 centimeter. So perimeter of the triangle ABC is 36 centimeter. Next question, fifth question. Side of the triangle are in the ratio 2:3:4 and its perimeter is 45 centimeter. Find its area. Let's take the side of the triangle ABC. So A plus B plus C. Perimeter of the triangle given here is 15 centimeter. So how to find ABC? The given ratio 2:3:4. So let's take side A is equal to 2x. Side B is equal to 3x, side C is equal to 4x. Whenever the ratio is given, we need to find that with the common factor so that we will get the correct measure of the side. Now 2x plus 3x plus 4x is equal to 45 centimeter. So 5 plus 4, 9x is equal to 45 centimeter. X is equal to 45 by 9. So x is equal to 5 centimeter. So if x is equal to 5 centimeter, each sides A is equal to 2 into 5, 10 centimeter. Length of one side is 10 centimeter. B is equal to 3 into 5, 15 centimeter. So next side is 15 centimeter. The third side 4 into 5 is equal to 20 centimeter. So if we are adding, we will be getting 45 centimeters. That is the perimeter is given. Now we need to find the area. So using Heron's formula, we can find area of triangle is equal to semi-perimeter. So what is the semi-perimeter? Yes, here is 45 by 2. 45 by 2 we are getting decimal, so we will keep as it is 45 by 2. So yes, 45 by 2, then 45 by 2 s minus a10, then 45 by 2 15 minus 15, then 45 by 2 minus 20, side C is 20 centimeters squared. Now 45 by 2. So for the subtraction, we need to take LCM, then only we have to subtract. 45 minus 20 by 2, then 45 minus 30 by 2, then 45 minus 40 by 2. Because one is rational number, another one is whole number. So we need to take LCM, then we can find the answer. 45 by 2 into 15 by 2, 25 by 2 into 15 by 2 into 5 by 2. Now 45 can written as 9 5s or 9 into 5 45, 5 into 5 25, 5 into 3 15, then 5, and denominator we are having 4 2s, 2 into 2 into 2. Now in numerator, if we are removing square root, 9 is a square number, so square root of 9 is 3. Then for these two 5, we can take 1 5 outside. For next two 5, we can take one more 5 outside. Then remaining 3 and 5 not at all having pairs, so 3 5s are 15, we can keep as it is. In denominator, for these two 2, we will be taking 1 2 outside, and another pair we will be getting one more 2 outside. Now 25 3s are 75 root 15 divided by 4. If we are dividing 75 by 4, this is centimeter squared. This is the area. So simplifying this, 75 divided by 4, if we are finding the division, 1 time 4, 35, then 8 4s are 32. Then keeping dot, 3 30, 7 times 28, then remaining 2 to 5 5. So 18.75, 18.75 square root of 15 centimeters squared is the area of the triangle. 18.75 square root of 15 centimeters squared. Next question, the side of a triangle have length 7 centimeter, 24 centimeter and 25 centimeter. Find the area of the triangle in two different ways. So two different ways, three sides given. So we can use Heron's formula to find the area. So if we are taking measure of A, one side A and another side B, another side C, means A is equal to 7 centimeter, B is equal to 24 centimeter, side C is equal to 25 centimeter, semi-perimeter S is equal to A plus B plus C by 2, 7 plus 24 plus 25 by 2. So 9 plus 7, 16, 56 by 2, 28 centimeter. Semi-perimeter is 28 centimeter. So S is equal to 28 centimeter. Area of triangle is equal to square root of 28, then 28 minus 7, then 28 minus second side 24, and 28 minus 25, the third side 25. Then 28 into 21, then 4 into 3. Now 28 can return us 7 fours or 4 into 7. Then 21 can return us 7 into 3. 4 is a square number, then we are getting 3. Now 4 is a square number, taking out of square root we will be getting 2. Then for these 2 7 we can remove 1, we can write 1 7. For these 3 for these 2 3's we can take 1. Then square root of 4 is 2. Now 7 2's are 14. 14 into 6. For calculating that, 14 into 6. 4 remaining to 84. So 84 centimeter squared is the area. So area of triangle, given triangle is equal to 84 centimeters squared. The another way, if the three, we need to use the formula half into base into height. For that, we have to check whether the three numbers are Pythagorean triplets or not. If suppose they are Pythagorean triplets, then we can consider this triangle as a right angle triangle, and we can find the area using half into base into height formula. So to check the Pythagorean triplets, the greatest measure squared is equal to sum of square of another two measures. That is, here the greater number is C. So we need to check whether A squared plus B squared is equal to C squared or not. 7 squared plus 24 squared is equal to 25 squared or not. We have to check. 7 7s are 49. 24 squared, 24 into 24, 16, 9, 8, 4, so 6, 526, 526, 25 squared, so 25 into 25, 5 5s are 25, 2 into 6, 625. You have to remember all the numbers, otherwise multiplied like this. So adding this 5, remaining 1 5. The other way, we have to check all the three sides are Pythagorean triplets or not. A is equal to 7, B is equal to 24, C is equal to 25. To check the Pythagorean triplets, largest side square is equal to sum of square of another two sides. Means these three numbers are Pythagorean triplets. That is, largest side here is C side C. So A squared plus B squared is C squared. Then we can consider 7, 24, 25 are Pythagorean triplets. Then it can form a right angle triangle. So we can use a formula half into base into height. 7 squared plus 24 squared is equal to 25 squared. 7 squared 49. 24 squared 576. 25 squared 625. So 5 remaining 1, yeah, 625 is equal to 625. Is A squared is A squared plus B squared is equal to C squared. So the three numbers are Pythagorean triplets, which is one leg is 7, another leg is the right angle triangle like this. It can form a right angle triangle, that is one leg is 24, another leg is 7, then the hypotenuse is 25. So base of the triangle we can take 24 centimeter or 7 centimeter, anything. Then height of the triangle is 7 centimeter. So area of triangle is equal to half into base into height, centimeter squared. So when we are cancelling this 12 into 7, 84 centimeter squared. So in this way also we can find the area, either Heron's formula, otherwise after checking the Pythagorean triplets form we can use the formula half into base into height. 7th question, If the wheel of a bicycle has a diameter 60 centimeter, find how far a cyclist will have traveled after the wheel has rotated 100 times. So we know very well, suppose we are taking, this is the total length should be covered. Say A to B is the total distance to be covered. Now suppose we are taking a wheel. Consider this is a wheel. So this is the wheel. If I am marking a point on the wheel, say this point, the wheel and the floor, the contact point is say X. Now the wheel is rotating one time and once again the X point is here. Once again we are seeing the position of the wheel here. Then second time again the wheel moved and we are seeing position of the wheel like this. After one rotation, if we are seeing like this, then the point, this is the point, this is X point, this is X point, this is X point, means the wheel can cover the distance. This is pi d, that is circumference of circle, pi d or 2 pi r, anything. So here one time 1 pi d, here 2 pi d, here 3 pi d, here 4 pi d, like that, to cover total distance n number of pi d's or n number of 2 pi r. So the total distance covered by a wheel is equal to, total distance is equal to n times circumference of the circle. Here diameter is given, so that we are using circumference of the circle is equal to pi d. So total distance is equal to the number of times, the rotation times here given 100. So n into 60 is given, so we can use the pi value 3.14 into diameter is 60, that is n here given 100 and diameter of the wheel is 60 centimeter. Why we are using 3.14 means calculation is a bit easy here. By multiplying 100 into 3.14, we will be getting 314 into 60, the distance we are covering, so centimeters. Now multiplying this 0, 24 remaining 2, 8, so centimeters, 18,840 centimeters, 18,840 centimeter, and one here the conversion is 1 meter is equal to 100 centimeter. So 1 centimeter is equal to 1 by 100 meters. When we are dividing this by 100, we will be getting 188 meters approximately. So approximate distance covered by a wheel is 188 meters. Eighth question, find the area of the quadrant of a circle whose circumference is 66 centimeter. So directly the radius or diameter is not given, circumference of the circle is given. Using that we need to find the radius. So here given circumference of circle is equal to 66 centimeter, that is 2 pi r is equal to 66 centimeter. 2 into 22 by 7 into r is equal to 66. So r is equal to, when we are transposing the number, 7 by 44, using 11 table 4 times and 6 times, using 2 table 3 times and 2 times. So r is equal to 3 into 7 by 2. Radius of the circle is 21 by 2 centimeters. Now area of the quadrant. Quadrant is 1/4 of the circle's area, 1/4 of pi r squared. So 1 by 4, 22 by 7 into r is 21 by 2. R squared, we no need to replace 21 by squared. We can write that twice. Then only the cancellations are easy. So we can cancel this 3 times. Then 2, 11 times. Now in numerator we are having 33 into 21. 11 into 3, 33, and 21, 33, and 66, 693. So in numerator we are having 693 divided by denominator 4 2s or 8 centimeter squared. Now dividing this 693 by 8. 8 8s are 64, remaining 5, 53. 6 times 48, then remaining 5. So we can write this 86 5 by 8 centimeters squared. So area of the quadrant when the circumference of the circle is 66 centimeters is 86 5 by 8 centimeter squared. Ninth question. The wheel of a car has an outer radius 28 centimeter. Calculate how far the car travel after one complete turn of the wheel and how many times the wheel turns during the journey 1 kilometer. Now here given radius of the wheel is 28 centimeter. In one rotation, what is the distance covered? We know that one rotation the distance is equal to 2 pi r. So one full rotation, one full turn, 2 pi r is equal to 2 into 22 by 7 into 28 centimeter. So cancelling this 4, 44 into 4. So 176 centimeter. For one turn, the wheel can cover 176 centimeter. The distance for one turn is 176 centimeter. They are asking for 1 kilometer, how many turns it will take. So here the radius is in centimeter and the distance given in kilometer. So we can convert. We know that 1 kilometer is equal to 1 lakh centimeter. Since we know the table, that is 10 millimeter is equal to 1 centimeter. 10 centimeter is equal to 1 decimeter. 10 decimeter is equal to 1 meter. 10 meter is equal to 1 decameter. 10 decameter is equal to 1 hectometer. 10 hectometer is equal to 1 kilometer. So 1 kilometer, 1, 2, 3, 4, 5 jumps. So 1 kilometer is equal to 1 lakh centimeters. We know that n times circumference of circle is equal to total distance. So in our question, n times 2 pi r is 176, that is equal to the distance covered here is 1 lakh. So n is equal to 1 lakh divided by 176. So approximately the answer is 568.18 approximately. So since it is a rotation, we cannot take it as decimal. So approximately it can cover 568 rotation. 568 number of time the wheel can rotate approximately. Now, two rectangles have the same area and same perimeter. Does this means that they are concurrent with each other? So, let's see. Take one triangle, rectangle. Say the rectangle. This is one rectangle. This is another rectangle. Rectangle A, rectangle B. The rectangle A side length is A and breadth is B. Rectangle B length is X and breadth is Y. Now, area of rectangle A is area of rectangle A is AB. Then perimeter of rectangle A is 2 into A plus B. Here area of rectangle B is xy and perimeter of rectangle B is 2 into x plus y. In the question it is given both the rectangles areas are equal, which means AB is equal to xy and perimeter also equal, which means 2 into A plus B is equal to 2 into x plus y. Cancelling 2, we will be having A plus B is equal to x plus y. That is, two numbers products are equal and sums are equal. That is, if either A is equal to x or A is equal to y. If A is equal to x, then B is equal to y. If A is equal to y or B is equal to x. So both the numbers are same. Product also same and sum also same means the numbers are same. So the two rectangles are concurrent to each other. Yes, the two rectangles are concurrent to each other since product and sum of two numbers are same. So area and perimeter also same. 11th sum. You know that the area of parallelogram is base into height. Using this and the figure, show that area of the trapezium is half the sum of the parallel side into height, that is half of A plus B into H. Now we can name the trapezium. If we are naming all the vertices A, B, C, D, E. When we are naming like this, we are having trapezium, we are having two figures. One is parallelogram and another one is triangle. That is parallelogram A, B, D, E and triangle B, C, D. These are the two division of the trapezium. A trapezium is divided into these two shapes. Now look at the length of the sides. Now E to D here given as A unit. That means opposite sides are equal in parallelogram. So A to B also A. Then height of the trapezium given here is H units. So when we are dropping a perpendicular from E, that is H. So base of the parallelogram is AB, which is A unit. Height of the parallelogram is H units, that is equal to A. And what about the triangle? When you are seeing the triangle, BC is the base of the triangle. This is the base of the triangle. When we are calculating BC, here given B unit, that is AC's length is B unit, AB length is A unit. So BC is nothing but total length B minus A. That is the base of the triangle. So base of the triangle is equal to BC. That BC can be calculated as AC minus AB. AC is B minus A. This is the base and height as usual H units. Now we know that area of the parallelogram. Area of parallelogram is equal to base into height square units. That is the formula for area of the parallelogram. So area of parallelogram A, B, D, E is equal to base AB into height. So AB is A and H square units. That is the area of the parallelogram. Now area of triangle is equal to half into base into height square units. So required triangle, area of triangle BCD is equal to half into base BC into height square units. So we got BC as half into B minus A into H square units. Now we're going to calculate area of trapezium ACDE, which is nothing but area of parallelogram ABDE plus area of triangle BCD. So area of parallelogram ABDE we got as AH square units plus triangle half of B minus A into H. Now removing the bracket, we are getting AH plus, multiply this with half, BH by 2 minus AH by 2. Now H is common, otherwise take LCM. 2AH plus BH minus AH by 2. Now 2AH minus AH, we are getting AH plus BH by 2. Here H by 2 is common. So we can write 1 by 2 into H into A plus B square units. This is the area of the trapezium. Half of H times A plus B, sum of the parallel sides, is the area of the trapezium. Now next question. By dividing a trapezium into two triangles, show that its area is half the sum of the parallel sides multiplied by the height. The same formula as the one given above. So by dividing the trapezium into two triangles. So when we are drawing a diagonal, we can get, suppose if we are joining this diagonal, we can divide a trapezium into two triangles. So one diagonal will divide the trapezium into two triangles. So A, B, C, D is the trapezium. So BD diagonal divided the trapezium into ABD triangle and BCD triangle. Now consider the height of the trapezium. Height is the perpendicular distance between the parallel side is the height. Consider the height of the trapezium. Let height of the trapezium is equal to H units. Then take base AB as A and DC as B. Then parallel sides. Parallel sides AB is equal to A units and CD is equal to B units. Now the diagonal BD divided the trapezium into two triangles. For the both the triangles, the height is same. That is, if we are dropping the perpendicular from D, that is H. That is the height of ABD. Suppose we are dropping the perpendicular here, that is also, this is also H. So both the triangles, otherwise you can take, you can extend here and get the height of the triangle BCD. So this is H. This is the height of the triangle. So now area of triangle ABD is equal to half into base AB into height square units. So AB, length of AB is AH square units. Now area of triangle BCD is equal to half into base CD into H square units. So CD length is B units, BH square units. Now area of trapezium ABCD is equal to area of triangle ABD plus area of triangle BCD. Area of triangle ABD, half of A plus H. This is half of B plus H. Half and H are common. So half of H into A plus B square units. So we got the same formula. Half of height into sum of the parallel sides is the area of the trapezium's formula. Now 13th question. Show how we can use two identical copies of trapezium to make a parallelogram. How will this give us the formula for the area of the trapezium? So we are here we can see two trapezium. If we are naming this A, B, C, D is a trapezium of base length trapezium whose base A and CD is B. Now here given two identical copies of the trapezium. So when we are inverting the trapezium ABCD, we are getting this shape ABCD. That is also trapezium, just we inverted that. So here we are having B, here we are having A. Now what about the height? Both height of the trapezium. Here also the height is H. Here also the height of the trapezium is H. Both the heights are same. Now when we are keeping second trapezium beside of first trapezium, we are joining these two trapezium, we are getting a parallelogram. So when we are joining this, we are getting a parallelogram, say P, Q, R, S. The full shape is a parallelogram. We joined here, that is, this is vertex A, B, C, D, and here inverted, and we joined like this. When we are joining like this, we are getting a trapezium. The side length, this A to B is A and C to D is B. Here C to D is B and A to B is A. And the height, when we are seeing the height of the trapezium, this is also H, this is also H. The distance between the parallel sides, H. So here when we are seeing area of parallelogram PQRS is equal to base into height. So base is PQ into height square units. PQ is nothing but sum of PQ is equal, we can write PQ AB plus CD into H. Length of AB is A and CD is B. A plus B into H square units. This is the area of the parallelogram. Now look at the diagram. How we got area of the parallelogram? We are joining two trapezium and got the parallelogram. So twice area of trapezium, identical trapeziums. So twice area of ABCD is equal to area of parallelogram. That is twice area of ABCD is equal to area of PQRS. Now twice area of ABCD is equal to area of PQRS, we got A plus B into H square units. So what is area of ABCD? That is area of each trapezium 1 by 2 A plus B of H square units. So this is the like this we got area of the trapezium from the parallelogram. So next 14th question. Show that area of the kite is half the product of its diagonal. Show this using algebra and using geometry. So let's we take a kite which is A, B, C, D is a kite. Here two diagonals are there. AC and BD are the diagonals. We know very well the diagonals are perpendicular to each other. We know that is BD is perpendicular to AC. This is the property of the kite, diagonal property of the kite. Diagonals are perpendicular to each other. Now say AC is equal to D1, diagonal 1, and BD is equal to diagonal 2. Now I am going to divide my diagonal, say take this point, the meeting point of two diagonals O. Now I am going to take OC is equal to A unit and OA is equal to A unit. Okay, OC is equal to A unit. Now let OC is equal to A units and OA is equal to B units. So I am going to take this is A and this is B. Now my diagonal, that is AC, AC is equal to OC plus OA. So OC is AC, AC is D1, D1 is equal to A plus B. So diagonal 1 is equal to A plus B. Now take the triangle. Area of triangle DBC is equal to half into BD, base, into OC, height square units. So half into BD is the diagonal 2, D2 into OC. OC here we got A square units. Now take next triangle. Area of triangle DBA. The diagonal BD divide the kite into two triangles. One triangle, so diagonal, this diagonal, that is DB diagonal, divide the kite into two triangles. One triangle is DBC, another triangle is DBA. So here we are having DB as D2 and the height, the perpendicular distance here is A. Here also D2, then perpendicular distance given here is B. So half into base, same base DB into different height OA square units. So half into DB is D2, OA is B square units. Now area of kite ABCD is equal to area of triangle DBC plus area of triangle DBA. So area of triangle DBC we got half into D2 into A plus DBA half into D2 into B. Now half into D2 is common when we are taking outside. Half into D2 into A plus B. Here we got our A plus B is equal to D1. So when we are replacing that, half into D2 into D1 square units. So this is the area of the kite ABCD, half into D2, D1 into D2 or D2 into D1, half into D1 into D2. So algebraically we got the area of the kite. Now geometrically we are going to find the area of the kite. Now let's take a rectangle. That rectangle should inscribe the kite. Now take the rectangle PQRS. Our kite is inside. So this is A, B, C, D kite. Now DB length is D2. So that our rectangle's length is, that is here PQ is equal to SR is equal to DB is equal to, what is our DB? Here we got DB D2, diagonal 2. Then PS, length of the rectangle PS is equal to QR is equal to, the diagonal length AC is equal to, here we got AC is equal to D1. So length of the rectangle is D1, breadth of the rectangle is D2. So area of rectangle PQRS is equal to D1 into D2 square units. Now look at here, we can see many triangles here. Say triangle 1 CDS, triangle 2, say this is O, COD, that is triangle 2. Now compare these two triangles, that is triangle SDC and triangle DOC. In that DC is common, DC is equal to DC, common sides. And what about the other sides? Here side SC is equal to this side DO, because parallels, so equal. then this side SD is equal to that triangle OC. So that triangle 1 is concurrent to triangle 2. So these two triangles, which means triangle SDC concurrent to triangle DOC. These two triangles are concurrent to each other. 1 and 2 concurrent to each other. In same way, 3 and 4 concurrent to each other. And 5 and 6 concurrent to each other. 7 and 8 concurrent to each other. The criteria, side criteria, both the triangles 1, 2 concurrent to each other, 3, 4 concurrent to each other. So similarly, we can write all the triangles. That is, here triangle 1 concurrent to, otherwise we can name it as triangle SDC concurrent to triangle OCD. Similarly, triangle 3 concurrent to triangle 4 and triangle 5 concurrent to triangle 6. Then triangle 7 concurrent to triangle 8. You don't write numbers, you write the letters of the triangle. Don't write numbers of the triangles. Okay. SD is equal to OC and DOD, and DC is equal to DC and DO is equal to SC is equal to DO. Yeah, correct. In the order, when we are writing the concurrency of the triangle, we should see the order of the letters. Okay, like that for all the triangles you write the letters. So all the triangles are concurrent to each other, which means the triangles, the rectangles area divided into two parts. That is, triangle 1, area of triangle 1 plus area of triangle when we are taking all the odd number triangles, that is area of triangle 1 plus area of triangle 3 plus area of triangle 5 plus area of triangle 7, which is equal to area of triangle 2 plus area of triangle 4 plus area of triangle 6. So the kite occupied exactly half of the rectangle space. So here area of kite ABCD is equal to half of area of rectangle PQRS. So that is equal to half of area of the rectangle we got here. Area of the rectangle D1 into D2, half of D1 into D2 square units. Like that, we can find area of the kite using geometry. Using the concurrency, we got area of the kite. Half of diagonal 1 into diagonal 2. Now, 15th question. 3 problems are fitting concurrent shapes together. The first one, rectangle ABCD has AB, sides AB. So, take this rectangle ABCD, sides AB. So, this side is A, this side is B, here also A, B. So, area AB. Now, PQRS 2A 2B. So, PQRS, this is the rectangle with sides 2A and here also 2A, 2B, 2B. So, area is 4AB. Length into breadth 4AB. So, this is given. Show that PQRS has 4 times the area of ABCD. Does this means that 4 copies of rectangle ABCD will fit into rectangle PQRS? Check and see. Now, we know that area of rectangle ABCD is equal to length AB into breadth BC. is equal to AB square units. Same way, area of rectangle PQRS is equal to length PQ into breadth QR. So 2A into 2B is equal to 4 times AB square units, which means 4 times, for instead of AB we can replace area of ABCD. So area of PQRS is equal to 4 times area of the rectangle ABCD. Of course, we can fit the rectangle, the small rectangle inside the big rectangle PQRS. How many rectangles we can fit here? We'll see. So this is our triangle PQRS. So this is PQRS. In this, this is one ABC. This is another ABCD rectangle. You use your graph sheet and draw it and check. We can fit four identical rectangles ABCD inside the rectangle PQRS. So like this we can fit 4 ABCD. So area of PQRS, when PQ's length is 2A and PQ's breadth is 2B, area of PQRS is equal to 4 times area of ABCD. A plus B plus C by 2, we can cancel 2 and 2. So semi-perimeter of PQRS is A plus B plus C. Now area of triangle ABC using herons, S into S minus A into S minus B into S minus C. So S is A plus B plus C by 2. S into A plus B plus C by 2 minus A. Then A plus B plus C by 2 minus B. Then A plus B plus C by 2 minus C under the square root. Now for calculating A plus B plus C by 2 into, take LCM, A plus B plus C minus 2A by 2, then A plus B plus C minus 2B by 2, then A plus B plus C minus 2C by 2. Now in first bracket no change, A plus B plus C by 2. For the second bracket we are having A minus 2A. So which is B plus C minus A by 2. Then third bracket we are having B minus 2B, that is minus B. So A plus C minus B by 2. Then third bracket we are having C minus 2C, which is A plus B minus C by 2. Now we are having 4 2's. So for these two we can take 1 2 outside. For these two we can take 1 2 outside. So 1/4 of A plus B plus C into B plus C minus A into A plus C minus B into A plus B minus C under the square root. So this is our area of triangle ABC. Now see the next area, that is PQRS area. Here area of semi-perimeter of PQRS given. One minute. Semi-perimeter of PQRS is A plus B plus C. So when we are applying the formula, area of PQR is equal to S into S minus 2A, S minus 2B, S minus 2C. Because the side length are 2A, 2B, 2C. So our S is A plus B plus C. So A plus B plus C minus 2A, A plus B plus C minus 2B, A plus B plus C minus 2C under the square root. So that is equal to A plus B plus C, then A, here A minus 2A is here, so B plus C minus A, then B minus 2B is minus B. So A plus C minus B, C minus 2C is minus C. So A plus B minus C under the square root. So we are having A plus B plus C. This is area of PQRS. So when we are seeing here, area of triangle ABC is equal to 1/4 of area of triangle PQR. So area of triangle, which implies area of triangle PQR is equal to 4 times area of triangle ABC. So we got. Let's check it. Shall we fix the triangle inside or not? So take a big triangle PQRS. When the areas are equal, we can fit the triangle inside it. Now this is triangle PQRS. Now let's check how many triangle we can fit inside ABC triangle. So this is one. Two. Second triangle. Here the third triangle. We can fit the third triangle here. Then fourth triangle. So if the side of the triangle is ABC, then it can four triangles can fit into the triangle of side 2A, 2B, 2C. So this side is 2A, here 2B, this is 2C, here A, B, C, A, B, C, and A, B, C, A, B, C. Like that we can fit 4 triangles. So area of triangle PQR is equal to area of triangle 4 times area of triangle ABC. Now triangle ABC has side ABC and PQRS has side 3A, 3B, 3C. So that PQRS has 4 times, 9 times area of ABC. Does this means that 9 copies of ABC will fit into PQRS? Check and see. Same way, using previous sum, we can take ABC, triangle side ABC. We no need to calculate once again the area. We can write the area because semi-perimeter we know that A plus B plus C. So, area of triangle ABC is equal to 1 by 4 times. Previous sum we got this result A plus B plus C into B plus C minus A, then C plus A minus B, then A plus B minus C. This is the result we got in previous question, triangle ABC. This is the triangle PQR. Side length 3A, 3B, 3C. So what about semi-perimeter? S is equal to 3A plus 3B plus 3C by 2. So semi-perimeter S is equal to 3 by 2 times A plus B plus C. That is the semi-perimeter. Now we can find the area. Area of triangle PQR is equal to semi-perimeter 3 by 2. 3 by 2 A plus B plus C. Then semi-perimeter 3 by 2. Otherwise we can keep the semi-perimeter as it is. Then the calculation is easy. No need to take 3 by 2 outside. Semi-perimeter keep as it is. Then easily we can calculate the area. That is for PQRS, the semi-perimeter is S is equal to 3A plus 3B plus 3C by 2. Keep as it is. So, here yes, 3A plus 3B plus 3C by 2. Then S minus A. 3A plus 3B plus 3C, yes, 3 by 2 minus A is 3A. Then 3A plus 3B plus 3C by 2 minus 3B. Then 3A plus 3B plus 3C by 2 minus 3C. Everything under the square root. Then 3A plus 3B plus 3C by 2. Now 3A plus 3B plus 3C, if we are taking LCM, we will be getting 6A by 2. Then 3A plus 3B plus 3C minus 6B by 2. And 3A plus 3B plus 3C minus 6C by 2. So, everything under the square root. Here 3A plus 3B plus 3C by 2. Then 3A minus 6A we will be getting minus 3A. So 3B plus 3C minus 3A by 2. Then 3B minus 6B we are getting minus 3B. So 3A plus 3C minus 3B by 2. Next 3C minus 6C minus 3C. So 3A plus 3B minus 3C by 2 under the root. So here for all the brackets 3 by 2 is common. So let's take 3 by 2 outside. That is 3 by 2 times a plus b plus c. Next 3 by 2 times b plus c minus a. And 3 by 2 times a plus c minus b. Then 3 by 2 times a plus b minus c under the root. Now for these two pairs we can take 1 3 by 2 outside. For these two pairs we can take 1 3 by 2 outside. So 3 by 2 into 3 by 2 outside of the square root, we will be getting under the root. Now we are having a plus b plus c into b plus c minus a into a plus c minus b into a plus b minus c. So we are multiplying this 9 by 2 times square root of a plus b plus c into b plus c minus a into c plus a minus b into a plus b minus c. So look at that, area of triangle ABC is 1/4 of ABC BC. The same we are getting. So which is equal to 9 times area of triangle ABC. So area of triangle PQRS, we got the result. Area of triangle PQR is equal to 9 times area of triangle ABC. The same we can check fitting the triangles inside the big triangle. So this is the triangle. No, here we can fit the triangle like this. If this is one, so like this we can fit two triangles. Then one more triangle. So totally we can see 9 triangles here. So this is triangle 1, this is triangle 2, this is triangle 3, this is triangle 4, this is triangle 5, this is 6, this is the triangle 7, this is 8, this is the triangle 9. So when the triangle side 3A, 3B, 3C, it can cover 9 times the triangle with side ABC. Sixteenth question. What fraction of the triangle is shaded? So let's name the triangle A, B, C. So triangle ABC, and we are having a division here. So take this vertex D, then this vertex E. So D and E are two vertices. Now in triangle ABC, in triangle ABC, we're going to join the vertices B and E. So when we are joining the vertices B and E, so we are getting a line like this. Then name one more vertex, this vertex as F. So now BDEF is a trapezium. It is divided into two triangles. So totally we are having four parts here. Take this is part 1, this is 2, this is 3, this is 4. Four parts are there. The triangle ABC divided into four parts. Now look at that. In triangle we can see many triangles here. I going to take a triangle AEB. I going to take a triangle AEB. You can see that the triangle AEB is this one. This is E. This is vertex A. This is vertex B. Here we are having a vertex F. This side is equal to this side, which means F is the midpoint of AB and EF is the median. So in triangle AEB, F is the midpoint. That implies EF is the median of triangle AEB. So it can divide, the median can divide the two equal area triangles. So that implies area of triangle AEF is equal to area of triangle BEF, which means area of 1 is equal to area of 2. We got this result. Next, in triangle, next triangle I am going to take BCE. So look at the triangle BCE, it is like this. The vertex B is here, the vertex E is here, the vertex C is here. Here we are seeing another vertex D. These two are equal, which means D is the midpoint and BD is the median. So it is given in the diagram. Since ED is equal to DC, BD is the median of the triangle. So that we are getting again two equal area triangles. Area of BDE is equal to area of triangle BDC. So what is given in the diagram? Area of the third portion is equal to area of the fourth portion. Now take the triangle, full triangle. Area of triangle ABC is equal to area of triangle AEF plus area of triangle BEF plus area of triangle BDE plus area of triangle BDC. So area of triangle ABC is equal to, these two are equal, no? Look at first equation. These two are equal, so we can replace, instead of AEF we can replace BEF. That is, area of AEF can be replaced as triangle's area BEF by 1. So by 2 we can replace area of triangle BEF as it is. So third area of BDE we can keep as it is, area of triangle BDE. Then area of triangle BDC we can replace using the second equation, again BDE. So the replacement happened by 1 and 2, equation 1 and 2. There we equated. So area of triangle ABC is equal to twice area of triangle BEF plus twice area of triangle BDE. So now area of triangle ABC is equal to 2 is common. If we are taking outside, area of triangle BEF plus area of triangle BDE. When we are combining, this is part 2, this is part 3. When we are combining 2 plus 3, we are getting a shape, trapezium shape. So area of triangle ABC is equal to twice area of BDEF. This is the shaded portion. BDEF is the shaded portion. So area of BDEF is equal to 1 by 2 area of triangle, the full triangle ABC. So the shaded portion is nothing but half of the whole triangle. So the question asked there, what fraction of the triangle is shaded? So 1 by 2 part of the triangle is shaded. So shaded portion is equal to 1 by 2. 1 by 2 portion. The whole half of the area is shaded here. Next question. What fraction of the square is shaded? Look at here. We are having a square. Name the square. A, B, C, D is the square. Then if you are naming this P, Q, R, S, what portion of PQR from ABC is shaded? For that, look at the second diagram. Like this, we can divide the square into equal parts. So count the parts now. If we are counting that, 1, 2, 3, 4, 5, 6, 7, 5 rows and 5 columns. 5 by 5, 25. So area of ABCD, square ABCD is equal to 25 square units. 25 squares are there. In that PQR, what are the covered portion in PQR? So here we can see this is 1. If we are shading here, see this part is 1 full square shaded. Then now this one, the pink color, when we are shading this and the remaining portion, that portion shaded here. So together another square, second squared. Now take the next shape. For this shape, here one portion, then here the leftover portion. So actually leftover is here, the same portion shaded here. Now look at this one. This is the next portion. So leftover, this is shaded here. So this is the fourth square. And one more square. So this square, here the leftover portion shaded here. So totally 5 colors are there. For each color, occupied area is a square. So area of PQRS is equal to 5 square units. So the shaded area, the shaded portion is equal to area of PQRS divided by the whole area ABCD is equal to 5 by 25 is equal to 1 by 5. So 1 by 5 parts is shaded here. Out of 5, 1 part is shaded. So out of 25, 5 part is shaded here. Now 17th question. What fraction of the rectangle is covered by the circle? So two diagrams are there. First diagram we are having 3 circles. Second diagram we are having 4 circles. So take the radius of the circle is R. So let's take the radius of the circle. So this is, if this is the center R, so diameter is 2R. Here are the same. Okay. Here also R plus R. Here also R plus R. So where the diameter is 2R. From this point to this point we are having 2R. Then this point to this point another 2R. Then this point to this point another 2R. Then this is one more 2R. So length of the rectangle is 2R plus 2R plus 2R, 6R. Breadth of the rectangle is 2R. So what we are going to do? Let radius of the circle is equal to R unit. So area of a circle is equal to pi R square units. Here 3 circles are there. Area of 3 circles is equal to 3 times pi R squared. Now length of rectangle is equal to 2R plus 2R plus 2R. 3 circles are there. So 3 diameters, 6R units. Breadth of the breadth of the rectangle is 2R units. This is also units. So area of the rectangle is length into breadth. Length is 6R, breadth is 2R. So that is equal to 12R square units. Now we need to find the portion. What fraction of the rectangle is covered. So to find the fraction, total area, that is total area is area of rectangle. Out of area of rectangle, we need to cover area of 3 circles. That is equal to 3 pi R squared divided by 12 R squared. So R squared cancel. 3 can cancel 12 4 times. That is equal to pi by 4. So the fractional part here is 5 by 4. Now let's see the next one. Now here the same. Radius of the circle is R, means this is 2R. This is 2R. Diameter of the circle is 2R. 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 So here how many 2Rs? 4 2Rs. Till this 2R. Till this another 2R. till this another 2r, and once again the breadth is 2r. So now 4 circles are there. We can write area of 4 circles is equal to 4 times pi r squared square units. Now length of rectangle is equal to 4 times 2r. So 8r units. Previously 3 times, 3 circles are there 3 times, now 4 times. No change in breadth. Breadth of rectangle same, 2r units. So area of rectangle is equal to length 8r into breadth 2r is equal to 16r squared. Now to find the fraction, area of 4 circles divided by area of rectangle is equal to 4 circles 4 pi r squared. Area of rectangle is length is 8r and breadth is 8r into 2r. So that is equal to 4 pi r squared, 16r squared. R squared cancel. It can give pi by 4 as the fractional value. So both the figures we are getting pi by 4th part is shaded here. The triangles occupies pi by 4th part, both the shapes. Now the next question 18. Use the above to make the conjecture about the area occupied by the circle fitted into a rectangle in the manner shown. Test your conjecture for particular case, 10 circles, 20 circles, 50 circles. Now we're going to find for 10 circles, 20 circles, 50 circles. So area, same thing, no changes here. That is radius of the circle is equal to r units. So area of 10 circles is equal to 10 times pi r squared. So area of 20 circles is equal to 20 times pi r squared. Area of 50 circles is equal to 50 times pi r squared square units. Now here 10 circles occupied means the length of rectangle is equal to 10 times 2r. So 20r is the length of the rectangle. Breadth of the rectangle, no change. The diameter is the breadth. So here length of the rectangle, when 20 circles are occupied, 20 times 2r. So length is 40r. No change in breadth. Breadth is 2r. Here length of the rectangle, when 50 circles are occupied, 50 into 2r, 100r. Breadth here is 2r units. What about area of rectangle? Length 20r into breadth 2r is equal to 40r squared. Here area of rectangle is equal to length 40r, breadth 2r is equal to 80r squared. Here area of rectangle, length 100r, breadth 2r is equal to 200r squared. Now to find the fraction, area of 10 circles divided by area of the rectangle, that is equal to 10 circles 10 pi r squared divided by 40 r squared. Cancel this. So pi by 4 is the fractional part. So here area of 20 circles divided by area of the rectangle is equal to 20 circles 20 pi r squared divided by 80 r squared. R squared cancel. 20 will divide 80 4 times. Once again pi by 4 is the fractional part. Here area of 50 circles divided by area of rectangle is equal to 150 pi r squared divided by 200 r squared. R squared cancel. We can cancel 0. This will divide 4 times. So pi by 4. For all the cases, we are getting pi by 4 as the fractional part, shaded part. So how many circles are increased there, that much of length also increased in the rectangle. So occupied area is same. If we are finding the general one here, let take the radius of the circle or units. So area of n circles, n number of circles, n pi r squared square units. So 10 circles means 10 pi r squared, 2 circles means 2 pi r squared, 4 circles 4 pi r squared. So n number of circles, n pi r squared. So when n numbers of circle is there, length of the rectangle is equal to n times the diameter, n times 2r units. So 2nr units is the length. Then in breadth no change, breadth of rectangle is equal to 2r units. So area of the rectangle is area of the rectangle is 2nr into 2r is equal to 4nr squared square units. To find the fraction, area of n circles divided by area of the rectangle. Area of n circles divided by area of rectangle is equal to n pi r squared divided by 4n r squared. Cancel r squared, n and n, that is equal to pi by 4. So how many circles are increased there, that much of length also, we can see the difference in length also. So only the occupied area is pi by 4. Question number 19. The figure shows 9 identical rectangles fitted together to make a large rectangle whose area is 72 centimeters square. Find the perimeter of each small rectangle. Let's name the large rectangle as A, B, C, D. So here given area of ABCD is 72 centimeter. So area of ABCD is equal to 72 square centimeters given in the question. And here given 9 identical rectangles fitted. So 9 times, if we are taking length and breadth, or the length is L and breadth is B, 9 times LB, 9 identical rectangles given. So 9 times LB is equal to 72 centimeters squared. So LB is equal to 8 centimeters squared. We got this relation first. Now here we are having rectangles, row wise 4 rectangles, first row 4 rectangles, second row 5 rectangles are placed, which means first row it placed length and breadth. So here also length, breadth, length, breadth, length, breadth. But in second row differently it placed, that is, this is the breadth, breadth and length, breadth and length, breadth and length, breadth and length, breadth and length. So first row lengthwise, second row breadthwise. Now when we are seeing the length AB is equal to 5 times B is there. Then CD is equal to 4 times L is there in the diagram. We know that opposite side of the rectangle equal. So AB is equal to CD, which means 5B is equal to 4L. So we are getting B is equal to 4 by 5L. This is our second relation. Now we are going to substitute B in first equation, in equation 1. So L into B is 4 by 5L is equal to 8. So 4 by 5 L squared, that is equal to 8 into 5 by 4. So L squared is equal to 2 times 2 5s are 10. L is equal to square root of 10 centimeter. So length is square root of 10 centimeter. What about breadth? Breadth is equal to 4 by 5 times of square root of 10 centimeter. So this is the breadth. Now finding perimeter of each small triangle. Perimeter of small rectangle, not triangle, sorry, rectangle is equal to 2 into L plus B. So that is equal to 2 into L is root 10 plus B is 4 by 5 times root 10 centimeter. So this is the perimeter of each. 20th question. Show that the area of the shaded blue triangle and shaded red triangle are equal. Find a way of cutting up the blue triangle into some number of pieces of red triangle. The pieces cover the red triangle. Now we'll take the whole triangle as ABC. A, B, C, D, E. A, B, E is the whole triangle, and here the line from the vertex to the point of trisection of the opposite side. So from vertex A, 3 lines or 4 lines are there. It is that line trisected the opposite side. That means BC is equal to CD is equal to DE. The lengths are equal. And when we are seeing the height from A to BC, when we are dropping the perpendicular, that is the height of the triangle. The same height we can calculate from here also. So all the 3 triangles are having same height. So height of all the 3 triangles is H. Now area of a triangle ABC is equal to half into base BC into H square units. Then area of triangle ADE is equal to half into base DE into H square units. Now here given BC is equal to DE, which means both the area of triangle ADE we can replace at half into BC into H. So area of triangle ABC is equal to area of triangle ADE. Both the areas are same. So we proved the blue triangle and red triangle both are having equal areas. Question number 21. The figure shows a quarter circle in a square. Its center is at one vertex and it passed through 2 adjacent vertices. There are 2 semicircles on 2 adjacent sides as diameters. They create the shaded region A and B. Show that AB have equal area. So look at the first figure. Here we can name the square as PQRS. This is the square PQRS. Okay, all the figures are same. PQRS. So the square PQRS. PQRS is the square. Now the second sentence it is given, its center is at one vertex and it passed through 2 adjacent vertices. A quarter part of a circle has center at one vertex, so take P, and adjacent sides PQ and PS. These are the 2 adjacent side, and this arc. This is the quarter part of a circle. It is inside a square. Say the side of a square as 2A. For example, say let's take the side of a square 2a. It includes the shaded region A and B. Now we're going to consider the unshaded region. This is one unshaded region. Let's take this is C, and another one unshaded region. Let's take that as D. So one unshaded region is C, another is D. So this is C, this is D. So two unshaded region. Now the quarter part of our circle, which is inside the square, include all the four regions, two shaded region and two unshaded regions. Now what is the area of this quadrant? This is the quadrant with radius 2a. So area of quadrant PQS is equal to 1 by 4 pi r squared is the formula for area of the quadrant, that is 1 by 4 pi. Our radius is 2a, 2a the whole squared is equal to pi by 4, 4a squared, cancel 4 and 4, we will be getting pi a squared. So this is the area of the quadrant, first part. So we got area of this quadrant, which includes all the four areas. That is, this is equal to 2 shaded region and 2 unshaded, A plus B shaded region, C plus D unshaded region. So it includes all, pi a squared includes all the four regions, A plus B plus C. Now here given, there are two semicircles on two adjacent side of diameter. Say this is one semicircle based on the side PQ, based on this side PQ, this is one semicircle. So this is the semicircle based on the side PQ. It includes the shaded region A and unshaded region B. So what is this? What is the area of this? That is area of semicircle based on PQ is equal to semicircle area pi r squared. So pi 1 by 2 pi r squared, 1 by 2 again there the r. What is the r here? So the side length is 2a. So this is the radius. This is the radius of this semicircle. Here this is 1a, this is 1a. So their radius is a. Based on side PQ, the radius is a, it is not 2a. So pi a squared, that is not 2a squared, pi a squared. Pi a squared, that is pi a squared by 2, that is the area, includes the area, encloses the region A plus D, shaded region and unshaded region, and another semicircle based on the side PS. So this is another semicircle. Look at PS. Based on this we are having one more semicircle. This is another semicircle. Here semicircle's diameter is 2a, so that semicircle's radius is a. It includes the area, shaded region A and unshaded region C. It includes two regions. So area of semicircle based on the side PS is equal to 1 by 2 pi r squared, which is a squared. So 1 by 2 pi a squared, that is equal to shaded region A and unshaded region C. Now add this two. If we need, we want to prove that, show that A and B have equal area. We need to prove area A is equal to B. Now compare this two. That is, if we are adding these two, that is our total area A plus B plus C plus D. When we are adding everything, we will be getting, say this is 1, this is 2. Add 1 plus 2. 1 plus 2 implies A plus D plus A plus C, which is equal to 1 by 2 pi a squared plus 1 by 2 pi a squared. So, a plus a, 2a. 2a plus d plus c is equal to 1 by 2 pi a squared plus 1 by 2 pi a squared is pi a squared. Half plus half is 1. So, pi a squared. Look at here, first equation, when we are having pi a squared is equal to a plus b plus c plus d, we can equate that. So, pi a squared is nothing but a plus b plus c plus d. Say this is our first equation. So, where we got this by 1. Now, here c plus d, we can cancel it. C plus d, both the sides we are having c plus d, we can cancel that too. So, remaining 2a is equal to a plus b. Transposing left side a to right side, 2a minus a is equal to b. 2a minus a is a. So, we are getting a is equal to b. So, both the shaded areas are equal. A is equal to B. Now, 22nd question. In figure, 4 semicircles have been drawn within the given square, whose side is 2 units. The center of these semicircles are the midpoints of the sides. They create a 4-petaled flower shown in blue color. Find the perimeter and area of the flowers. So, look at the diagram here. Side of the square is 2 units. Now, when we are drawing the line here, it is given the center of the petal is the midpoint of the sides. So, when we are drawing parallel line for the horizontal side, and one more line, vertical line, we will be getting midpoints of the sides. Midpoint of the sides, that is the center of the petal. Now, say this is O. This is the center of the petal. O is the center of the petal, midpoint. It is given midpoint. So, if we are naming A, B, C, if we are giving P, Q, R, S is the square and the midpoint A, B, C, D, length of PQ is 2 unit. So, length of AQ is 1 unit. This is 1 unit, this is 1 unit. So, that OA also 1 unit. So, everywhere this is also 1 unit, 1 unit, like this. Now, we are having 4 petals. Look at the 4 petals. 2 petals based on each side. Based on PQ, we could see the length of 2 petals. This is one portion of one petal. This is another portion of another petal. This is the semicircle based on PQ. Same way, based on QR, this is another semicircle covering 2 petals sides. This is another semicircle. Then, based on SR, this is another semicircle. So, here we can see another semicircle, third semicircle. Then, based on PS, we can see the fourth semicircle. So, 4 semicircles can cover all the 4 petals. If we calculated the length of this semicircle, that is nothing but 4 times the length of the semicircle is the perimeter of the petal. Now, semicircle, we know that circumference of circle, that is arc length of the circle is 2 pi r. Arc length of the circle is 2 pi r. So, arc length of semicircle is half of 2 pi r, which is nothing but pi r. So, here we are having four semicircles with radius 1 unit. R is equal to 1 unit given in the question. R is equal to 1 unit. So, a perimeter of 4 petaled flower. Perimeter of 4 petaled flower is equal to 4 times pi r. 4 times semicircle's arc length. 4 times pi r. So, r is 1. So, 4 pi r units. That is the perimeter of the petals. Yes. Yellow color, one semicircle, red color, another semicircle, pink color, third semicircle, green color, fourth semicircle. So, if we are calculating all the length, semicircle arc length is pi r, 4 times pi r is the perimeter of the semicircle. Now, to calculate the area, in this, if you want to calculate the area, draw the diagonals. That is, this is sides midpoint. We know that these are the lines parallel to the sides, and it is given the midpoint of the petals. So, now if we are joining the diagonals, that is diagonal SQ, when we are joining diagonal SQ, the vertices, when we are joining vertices S and Q, we are getting one diagonal, and when we are joining the vertices P and Q, we are getting another diagonal. Now, we can get 8 parts of the petals. 4 petals are there, but we could see now 8 parts of the petals. So, look at here. Here, this is 1, 2, 3, 4, 5, 6, 7, 8. 8 parts are there in this diagram. So, each part, each 1 and 2 and 3, everything you can see here, it is the segment of a sector. For example, I am going to take my 1. If I am going to consider the segment 1 means, I have to take this sector. If we are covering this, we can get one sector. So, forget about the portion 8. If we are taking this is the sector. So, now we can see separately, I am drawing here. So, this is the sector of angle 90 degree of radius 1 units. And when we are joining this line, if we are joining the chord, this is our required portion. This is the segment. So, how to find the area of a segment? Area of segment 1 is equal to area of sector, that is sector, this is O, no, here O. So, we are having O, A, Q. This is our sector. Sector OAQ, sector OAQ minus triangle OAQ. So, now the triangle is a right angled triangle. So, triangle, right angle triangle, and the sector is a quadrant. Otherwise, we can replace 90 by 360 pi r squared minus right angle triangle half base into height. So, 90 by 360, 1 by 4 pi r squared, radius is 1 unit minus 1 by 2, base also 1 unit and radius also 1 unit. Half into, here rectangle base 1 unit and height 1 unit. So, when you are calculating pi by 4 minus 1 by 2 square units is area of segment 1. Same way we can calculate any other segment also. All the segments are having same radius, so all the segments will have same area. For example, we can calculate segment 5. If we want to calculate segment 5, this is segment 5, we need to enclose this one, this sector. So area of segment 5 is nothing but, roughly I can draw and calculate. Look at here, this is area of segment 5. So here 5, so we are having COS, radius 1 and 1. Again we have to calculate area of segment 5 is equal to area of sector, that is quadrant, 1 by 4 pi r squared is 1 minus area of right angle triangle 1 by 2 1 into 1, same thing, pi by 4 minus 1 by 2. This is area of segment 5. So like that we can find all the 8 segments. So totally area of 4 petaled flower is equal to 8 times area of segment. So 8 into pi by 4 minus 1 by 2 square units. When we are taking 8 inside, 8 pi by 4 minus 8 by 2 square units. So 2 pi minus 4 square units. Otherwise twice pi minus 2. If we are replacing pi value, when we replaced pi value, we will be getting 2 into 22 by 7 minus 4. So 44 minus 28 by 7 is equal to 16 by 7 square units. Now to calculate the area, we can join the diagonals. Let's join P and R. When we are joining the vertices P and R, we are getting one diagonal. As well, if we are joining Q and S, we are getting another diagonal. Now we can see 8 parts of the petals. So look at here, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 parts of the petals. Now we're going to find each part's area. So now I'm going to find part 2. Part 2 is the segment of the sector OAQ. So part 2 is the segment of the sector OAQ. We know that the center point is O. Now OAQ is the sector. In that portion, forget about part 1. Now just consider part 2. So this is the sector. That is OAQ is the sector. If we are drawing a card, we can see this is the segment. This is part 2. So to calculate area of part 2, area of part 2 is equal to area of segment OAQ. Area of segment OAQ is nothing but area of sector OAQ minus area of triangle OAQ. So we know that this is 1 unit, this is 1 unit. So radius of the sector is 1 unit, and the triangle here 90 degree. The triangle is right angled triangle. So area of the sector with 90 degrees, that is the quadrant, 1 by 4 pi r squared plus 1 by 2 base into height. Base is AQ and height is AO. Now 1 by 4 radius r is 1 unit. So 1 by 4 pi plus 1 by 2 AB is 1 unit. AQ also 1 unit. So pi by 4 plus 1 by 2 square units. This is area of part 2, one part of the petal. Same way we can calculate any other part also. Now for example, I am going to calculate part 6. So look at here, this is part 6. It encloses the sector COS. COS. Now to calculate part 6, this is COS. Here we are having the segment. This is part 6. So area of part 6 again. Radius is 1 unit. This is 90 degree. The same thing. Area of part 6 is equal to area of sector OCS minus area of triangle OCS. So 1 by 4 pi r squared minus 1 by 2, 1 into 1. So same one we are getting pi by 4 minus 1 by 2 square unit. So each part of the petal having area 1 by 4 minus 1 by 2 square units. There are 8 parts. So area of 4 petaled flower. Area of 4 petaled flower. So area of 4 petaled flower is equal to 8 times area of segment. So 8 times pi by 4 minus 1 by 2 square unit. So to simplify this, inside the bracket, if we are taking LCM, we will be getting pi minus 2 by 4 square units. We can cancel this 2 times. So 2 into pi minus 2, we are getting here 2 into pi minus 2 square unit, replacing the value of pi 22 by 7 minus 2, we will be getting twice 22 minus 14 by 7 is equal to twice 8 by 7, which is equal to 16 by 7 square units. So this is the area of the 4 petaled flower. Now question number 23. In the given figure, we see 2 concentric circles with the common center O. So you know that concentric circle, 2 or more circle with same center is the called the concentric circles. So here we are having 2 concentric circles with center O, and a chord BC of the larger circle is drawn touching the smaller circle at A. So look at the diagram here. At A, you can see the chord BC touching the smaller circle at A. The length of BC is L, so that area of the green region enclosed between the 2 circles is 1 by 4 pi L squared. So here, now if we are drawing the radius of the small circle, if we are joining O and L, we can get radius of the small circle. So this is radius of the small circle. Say this is small r. Radius of the small circle is small r, and consider radius of the larger circle as capital R. Now joining O to C, we can get radius of the larger circle. Now, smaller circle radiuses are larger circle is radius is capital R. We know that from a chord to a center, the line is there which is perpendicular to the center. This is 90 degree. So, O 90 degree. If we are naming, so OA is perpendicular to BC, which means AC is equal to L by 2 units. BC is L unit, AC is half of L by 2 units. In triangle OAC, we can calculate all the sides. For example, R, capital R is the hypotenuse. R squared is equal to small r squared plus L squared by 4. L by 2 the whole squared is L squared by 2. If we want to calculate small r squared means hypotenuse capital R squared minus L squared by 4. Now we need to calculate the region. This is the region, the green color region. To calculate that green color region, that is area of the outer circle minus area of the inner circle. Area of the green region is equal to area of outer circle minus area of inner circle. So, area of outer circle with radius capital R is pi r squared minus area of inner circle with radius small r is pi small r squared. Pi is common and capital R squared minus small r squared. Now, we are having the result for capital R squared and small r squared. We can replace any one thing here. Now, I am going to replace for small r squared. So, keeping capital R squared as it is minus of small r squared is capital R squared minus L squared by 4. Now, removing the bracket, pi into r squared minus r squared, then minus into minus becomes plus L squared by 4. Now, minus r squared, capital R squared and plus capital R squared cancelled. So, we will be getting pi L squared by 4. So, that is the required on 1 by 4 pi L squared. So, area of the green region is 1 by 4 times pi L squared square units. That is the area of the green region. Question number 24. In figure, semicircle have been drawn in all the sides of the right angled triangle as shown. So that area A plus area B is equal to area C. So we can see here triangle area is C and this portion is B, this is A. I think it is visible for you, A, B. So this portion is A, that is not semicircle portion, a portion of a semicircle. A, C and B. Now I am going to name the triangle X. This vertex is X and this is Y. This is Z, X, Y, Z. So, X, Y, Z is the triangle, right angled triangle. X, Y, Z. So, X, Y, Z is the right angled triangle. Suppose I am going to name the sides. Length of side XY is P. Length of side YZ is Q and this is R. So, P, Q, R. P, Q, R. P, Q, R. Now we are going to calculate. Now first I am going to calculate area of the triangle. Area of triangle XYZ, which is right angle triangle, that is nothing but C. Area of triangle XYZ, that is C's area is equal to half into base XY into height XZ. So half into P into Q. So this is area of the triangle. So we are getting C is equal to half PQ. That implies twice C is equal to PQ. This is one result we got. Now look at the second diagram. Based on the sides, I am going to take a semicircle. Based on XY, we can see the semicircle. This is the semicircle based on xy. So xy length is p. The semicircle has the diameter p by 2. Diameter p, so the radius, here the radius is p by 2. Radius of that semicircle is p by 2. So area of semicircle based on the side xy. So xy is the diameter, xy is p. So semicircle area pi 1 by 2 pi r squared. So 1 by 2 pi into p by 2 the whole squared is equal to pi by 2 into p by 4, p squared by 4. That is equal to pi p squared by 8 square units. This is area of one semicircle. Now look at area of the next semicircle based on the side xz. This one again, the diameter is q, so the radius is q by 2. Now area of semicircle based on the side xz, the diameter of that is q, so radius is q by 2 the whole square. So pi by 2 into q squared by 4 is equal to pi q squared by 8 square units. That is area of the next semicircle. Now look at here, third, based on the hypotenuse, we can see another semicircle here. Based on the hypotenuse r, we can see another semicircle. So r is the diameter of the semicircle, so radius is r by 2. Area of semicircle based on the side yz is equal to half into pi into r by 2 squared. So pi by 2 into r squared by 4 is equal to pi r squared by 8 square units. Now we need to find area of only the portion A and B. In that A and B, the portion, this one is overlapped. Here you can see the overlapped portion. This portion is overlapped. That is, when we are calculating the semicircle, we are including this portion also. We need to remove that portion. So area of A plus area of B is equal to area of semicircle based on xy plus area of semicircle based on yz plus triangle, area of triangle xyz. So when we are adding everything, we need to remove the enclosed one, that is minus area of semicircle based on the side yz. So when we are subtracting this, we will be getting only the area of the shaded region A and B. Area of semicircle based on xy is, we got here 1 by 2, sorry, pi p squared by 8. See xy, here we are getting pi p squared by 8 plus yz we are getting pi yz, wait 1 minute, not yz, xy and xz. This is xz, second one is xz. Area of xy plus area of xz plus area of the triangle minus area of yz. So area of xz, we are getting xz, this is xz, pi q squared by 8 plus area of triangle, we are getting C is equal to 1 by 2 pq minus semicircle based yz is equal to pi r squared by 8. Now combine pi p squared by 8, pi q squared by 8 and pi r squared by 8. So pi is common. So p squared, pi by 8 is common, p squared plus q squared minus r squared plus pr by 2. Otherwise 1 by 2 pr. Now in our triangle PQR is the side of the right angle triangle. We know that this is the right angle triangle, P is the side, one side, another side, this is R. Using Pythagoras, we are getting P squared plus Q squared is equal to R squared. When we are replacing that, this P squared plus Q squared is R squared minus R squared plus PR by 2. R squared minus R squared 0. So that is equal to 1 by 2 PR. So area of A and B is equal to 1 by 2 PR, that is equal 1 by 2 PQ. 1 by 2 PQ, that is not PR, 1 by 2 PQ, which is here we are having the first step, we got the answer. Area of the triangle is equal to 1 by 2 PQ. So that is equal to area of C. So area of A plus B is equal to area of C. 25th question. In the given figure, shows two circles passing through each other's centers. Find the area of the region enclosed by the two circles in terms of the common radius r. Now you can see two circles. Say this is circle 1 with center A. Then this is circle 2 with center B. Now C1 passing through center B, C2 passing through center A. So when we are drawing a line, C1 center A to its boundary point, that is the radius. Then B to that boundary point, that is also the radius. Then join AC and BC, everything are radius. So R, here also R, here also R. So this is a equilateral triangle. ABC is an equilateral triangle with angle 60, 60, 60. This angle is 60, here also 60. All the angles are same. If we are joining the vertices AD and BD, then also we are getting one equilateral triangle ABD. So this angle again 60. So angle at A, 60 plus 60, 120 degree. Now angle at A, total angle at A, we are getting 60 plus 60, 120 degree, because we are getting two equilateral triangles. This is 60, that is 60, 60 plus 60, 120 degree. Now what we are going to do, we are going to find the area using two segments. Suppose I am going to draw the line. If I am drawing the common chord, I am joining B and C. So this is common chord. If we are joining B and C, yes. So now we can see a sector. If joining AC and AD enclosed the arc length DBC, this is the sector. So this is a sector. In this sector, this is segment. In that sector, we can find this segment length. So sector with angle, previous diagram we got the angle, sector with angle 120 degree. Sector with angle 120, this angle is 120 degree. And radius R, this is also R, this is also R. And this is also R. To find the segment, area of sector with 120 degree minus equilateral triangle. In same way, we need to find the area of the shaded region in terms of R. So second diagram, we got area of the one part of area of the shaded region. To calculate another part of shaded region, we can join this one. So this is the another part. This is the another part. Again, this is the segment when we are joining these two. When we are joining this two, this is another segment. So this segment also having radius R, this is R, here also R, and angle again 120 degree. This angle is 120 degree. This is also R, equilateral triangle. So now area of segment, D CBD is equal to area of corresponding sector OADBC minus area of triangle ADC. So sector angle 120 degree by 360 degree, pi radius is R squared, so no change, minus equilateral triangle, area of equilateral triangle root 3 by 4, side squared R squared, square units. This is area of one segment. So 0, 0 cancel, 12 can cancel 360 3 times. Now pi R squared by 3 minus root 3 R squared by 4 square units. This is area of one segment. Like that, similarly we can get area of another segment, which is nothing but CAD. So area of the shaded region, area of region enclosed by two circles, region enclosed by two circles is equal to area of segment ADBC plus area of segment ABC, not ADC, area of segment two segments, area of segment ACD plus area of segment ABC, BCD, area of segment ACD, area of segment BCD. So twice pi R squared by 3 minus root 3 R squared by 4 square units. In this, R squared is common, so we can take R squared outside. So 2 times R squared, pi by 3 minus root 3 by 4 square units. Otherwise, R squared we are taking 2 inside, 2 pi by 3 minus root 3 by 2 square units. So this is the enclosed area in terms of R. Next, 26th question. In figure, we see three triangles within the rectangle. The area of the triangle are ABC as marked. So this is A, blue color, this is A. So that the area of the rectangle is equal to, area of the rectangle is twice A plus C into B plus C divided by C. By C. So we need to prove this. Now, once again mark the sides. I am going to name the triangle. Three triangles are there. If we are naming the triangle, say rectangle PQRS, naming the rectangle as PQRS is the rectangle. So this is the point O. So triangle, the three triangles are there. Now say the length of the triangles. Say OT, length of OT is P units, length of OU is Q units. Then if OT is P units, then length of UR also P units. Length of OU is Q units, means length of QR also U units. So this is P, Q. If this is P, parallel, this side also P, this side is Q. Now, the next remaining part here, this perpendicular, suppose we are naming that as R, here we are getting R. This portion, suppose S, here we are getting S. So these are the things. Now, in rectangle, the side length, that is SR is equal to PQ is equal to R plus P. Then next side, PS is equal to QR, side length of the rectangle is equal to Q plus S. So area of rectangle PQRS is equal to base into length into breadth. Length is R plus P, breadth is Q plus S square units. This is area of rectangle. Now consider area of triangle OTU. Area of triangle OTU, that is nothing but C. Here mentioned as C. Base is half into, base is P and height is Q. So C is equal to PQ, which implies 2C is equal to PQ. Then next, area of triangle, next triangle OUP. There the perpendiculars are Q and R. So the enclosed area of A half into Q. Q is the base and R is the height. So twice A is equal to QR. And area of triangle OPT. OPT is equal to enclosed area B, that is equal to half into base P and height S. So 2B is equal to PS. So we are getting this. Now we need to prove that area of rectangle is equal to twice A plus C into B plus C by C. So for that, what to do? We can add all the things. That is 2A plus 2B plus 2C is equal to, otherwise, area of rectangle PQRS, we are getting R plus P into Q plus S. From that we can derive. Now distributing R plus QS plus P into QS. When we are multiplying two binomial expression, split R plus P as R into Q plus S and P into Q plus S. Now distribute R. So RQ plus RS plus PQ plus PS. We are getting this relation. Now replace for RQ. Whatever is required, we can replace. RQ. We are having three results. One is 2C is equal to PQ. So where is PQ? We can replace 2C, and 2A is equal to QR. So we are having QR. First RQ or QR, both are same. Instead of that, we can replace 2A, and 2B is equal to PS. So we are not at all having RS. So keep RS as it is. Instead of PQ, we can replace 2S. Instead of PS, we can replace 2B. So now we are not having RS. So what to do? That four parts we are having. One is R, S and PQ. So what is left over there? Multiply and divide PQ with RS. So multiply and divide PQ. When we are multiplying same thing and dividing, we are not at all changing the value, but we are changing the expression. But we are not changing the value because PQ cancelled, we will be getting 1. 1 into RS is RS. We are not changing its value, but we are changing the expression. So when we are multiplying this, PQRS divided by PQ plus 2A plus 2C plus 2B. Now combine PQRS. So where we are having, we are PQ, the value of PQ we got in the first box as 2C. The value of RS we are not having, so change the combination. Change PS. PS we are having 2B and QR, combine QR. QR we are having 2A. So instead of PS, we can replace 2B. And instead of QR, we can replace 2A divided by PQ, we can replace 2C plus 2A plus 2C plus 2B as it is without any change. Now, in numerator, we can cancel 1, 2 because that is there in the product. So, we can cancel 1, 2. So, 2AB by C plus 2A plus 2B plus 2C. Now, take LCM. 2AB plus 2AC plus 2BC plus 2C squared divided by C. Now, combine it. From the first two, if we are taking from first two, if we are taking 2A as common, the rest of the letters B plus C. For next two expression, if we are taking 2C as common, the remaining B plus C. Taking LCM, 2AB plus 2AC plus 2BC plus 2C squared divided by C. Now from first two, we can take 2A common. So remaining B plus C. From next two terms, we can take 2C common. So remaining terms B plus C divided by C. Now B plus C is common when we are taking outside. The remaining factors 2A plus 2C divided by C. Now second factor 2 is common when we are taking outside. 2 times A plus C into B plus C divided by C. This is the required thing. So area of triangle PQRS is equal to twice A plus C into B plus C by C. So we got the result. Question number 27. In the figure, we see two shaded regions formed by the quarter circle, a semicircle and a triangle. Show that area of the two shaded region are equal. So this is region A. Say this is region A, this is region B. We need to prove region A is equal to region B. Now, this is the AC. ACB is a semicircle, so take radius. OA is R, so OC also R, OB also R. Now, area of triangle. Area of triangle OAB. OAB is equal to half into base OA and height OB. So area of region A is equal to half into R is equal to R squared by 2. So area of the region enclosed by A is this. Say this is 1. Now in right angle triangle AOB, to find side length B, AB is the hypotenuse. So that is equal to OA squared plus OB squared. Using Pythagoras, we can find the side length of AB. So OA is R squared, OB also R squared. So AB is equal to square root of 2R squared is R root 2 units. That is length of AB. Now AB, based on AB we can see the semicircle. Based on AB we could see a semicircle. In that semicircle only we are having the region B. So to find B in this semicircle we need to remove the segments area. If we are subtracting this segment area from the semicircle, we can get the area, exact area of B. The radius of that semicircle's diameter is r root 2. Semicircle based on the side AB, diameter is r root 2. So radius is r root 2 by 2 units. So area of semicircle AEB is equal to 1 by 2 pi r squared. 1 by 2 pi r squared is r root 2 by 2 the whole squared. So that is equal to 1 by 2 pi r squared into 2 by 4 square units. So cancelling this 2, we will be getting pi r squared by 4 square units. Now this segment area, to calculate that segment area, we need to get the sector. So to calculate this segment area, this sector area minus the right angle triangle area is that segment area. Now area enclosed by the letter B. Area of B is equal to area of semicircle which we found here AEB minus area of segment AFB. We have to subtract that segment's area. So to subtracting that segment area, we have to subtract area of sector minus area of triangle. Area of semicircle pi r squared by 4 minus area of segment is area of sector AOBF minus area of triangle AOB. So pi r squared by 4 minus of area of sector 1 by 4 pi r squared, because that is the quadrant, minus 1 by 2 r squared, that is right angle triangle which has legs, both the legs are same, r and r. So that is equal to pi r squared by 4 minus, to removing the bracket we will be getting pi r squared by 4 minus into minus is plus r squared by 2. So cancelling plus and minus, we will be getting r squared by 2. That is area enclosed by the shaded region B. This is 2. So already we got there 1. That is also r squared by 2. This is also r squared by 2. So from 1 and 2, A is equal to B. Area of A is equal to area of B.